great to be invited and take part in the workshop today. I really enjoyed the last presentation. I thought that was great, talking about soil health and how it relates to biologicals and success with biologicals. And it's something that is quite close to me and how I approach things as well. And I mean, we know that biologicals are really here to stay. There's so many different ways that biologicals can help agriculture and help us produce things sustainably. There's different reasons for using them, right? And there's different pressures on the adoption of biologicals in agriculture. But I think it's really crucial to recognize that it has to be done right. And we see a lot of newcomers into the marketplace. We saw that in one of the previous presentations. I mean, there's just so many of you guys as researchers and consultants. There's no shortage of new companies that are out there. And that's really what I want to explore today is how we can be successful as an industry with biologicals and how we can approach it successfully. And to do that, I think I'd like to take a look at the past a little bit and look at what was done in some of the development years in the 90s and early 2000s and how it was very different from today. And not all of the regulations, but some of the regulations around that early introduction of microbials and biologicals in agriculture to where we are now in this very much a buyer beware market. So kind of wanted to do that and look at some of the original type of research and what happened and even how some of the universities were involved. And then I wanted to kind of look at kind of what happens today and how we can possibly do things better moving forward. So that's kind of the approach I wanted to take, and hopefully you find it interesting. I've been working with biologicals for, just over 11 years now. I'm John Treloar. I'm a technical agronomist with Novozymes BioAg, and been working with the portfolio since about 2013. I've done a lot of trials out in the field, managed a couple different trial programs, whether that be grower trials on farm, and then I've placed literally thousands of small plot trials in Canada with CROs, third-party cooperators, and also do a lot of technical talks on biologicals, whether that's webinars, whether that's retail talks, grower talks, but really been solely focused on biologicals and being successful with them. I live in Saskatoon, and I wouldn't be from the prairies if I didn't talk a little bit about the weather, but for about the last 6 days, woken up to minus 50 with the wind chill. So it's been pretty rough week here, and nobody's really loving that, but I think it's going to break here in the next 24 hours down to only minus 20. So a little bit about me, but my information's on there, and if you ever want to chat or reach out, that's great. But kind of jump into the presentation and try to make up a little bit of time here. Now, one of the things that some people don't realize is that biologicals have been around for a long time. Long before any of the chemical inputs that we put into agriculture, biologicals were out there, and it really started in about the late 1800s with a couple of German scientists. And they discovered that when they ground up pea roots and put them back on pea seed, they got a better crop. And at the time, they called them germs. They didn't know that they were rhizobia, bacteria with the whole nodulation process. But they knew they were onto something. And they moved into the United States and formed the Nitrogen Company. And that exists today in our portfolio. It's one of our legacy companies through acquisition, mergers, things like that. But our knowledge base does go back about 130 years in working with biologicals in agriculture. So it's not new per se, but there's definitely a renewed interest in biologicals or a resounding interest in biologicals. And as you guys are at trade shows and places like Commodity Classic, you'll just see dozens and dozens, I won't say hundreds of booths with new products, new technologies. It gets really noisy, right? And there's wild claims. I mean, we saw in the last presentation or a couple of presentations ago, that cluster of all the different companies involved in biologicals. All the major, ag companies are having biological divisions. We're seeing growth year over year. But, to me, there's still a lot of noise out there. There's still a lot, what I said on the next slide really is that sometimes it seems like marketing is winning, that a company sees some opportunity here, no biologicals is big, have a way to produce a product and just want to get it out into the marketplace without a lot of attention on, say, modes of action, without a lot of attention on agronomic fits. Little bit of science is sprinkled into it, and off we go. and I'm not picking on anyone in particular, but I mean, you'll see a lot of the yield bar graphs making wild claims. As you dig into things, you don't necessarily, get the feeling that this is a really robust product and it's backed up by great science and great agronomy and great data. There's some out there, came across one that over 10 years of research and development and trials all over, and they basically published 2 trials and small plot from somewhere in Montana, and that's what they go with, right? So data is a really interesting piece of the whole biological thing, but I think that there's a lot of marketing and a lot of money behind some startup companies that are trying to get out there and be front and center. And what happens, I think, then is that if the products are not living up to their claims, if they're not being used in the agronomic patterns it should be, right, people are disappointed, and then we get just back into the whole snake oil realm. And trust me, I've been involved in this for over a decade now. The foo-foo dust, the bugs in the jug, the snake oil. I mean, I've basically heard it all. And the biological industry sometimes does that to themselves when they're overpromised and underdelivered. It's not living up to some of the claims, or it's marketed as a panacea that you can really put this on every acre and expect your 10% yield increases. And people have those experiences, and it's back to, well, the biologicals didn't work for me, and so that stuff, back to the snake oil realm. And so that's what we really want to get out of is having better experiences with biologicals, and I think that can be done through great research and great product development, and getting back to some of the basics, that it's not just about marketing and making a buck, it's about actually putting these things to work and doing it well. And so the way I look at it really is that we're part of an integrated program, that biologicals aren't going to provide the entire solution, but if used properly, that we can be part of the solution. And I think if you look at something like pest management, particularly in the horticulture realm and greenhouses, how they've used integrated pest management for 40 years or more now, and looking at a number of different factors in order to solve problems. And I think we can do that with fertility as well, that biofertility in an overall fertility plant. And if we look at something like penicillium villi and look at phosphorus solubilization and say, okay, we can deliver 20 pounds an acre of available phosphorus. And this is kind of how to do it. This is what to expect. And this is why we say 20 pounds. We're not the phosphorus solution, but we're part of that integrated approach. And I think that becomes really, really important. And as we heard from the previous speaker, it's also about building up those environments that harbor biological life and support microbial growth. And that, if we do that correctly, the products have a much, much better chance of working. And then on the, extreme end, say the regenerative agriculture end, we go back to, well, if we do everything right, we don't need those bugs in the jug. And that's great. If you have that system dialed in, then that's something everybody should be using. But when you have a pathogen, when you have a root rot, when you have a nutrient deficiency, and you add a biological into that system with great organic matter and great moisture management, great tilth of the soil, cover crops, things like that, then you've got an environment where these bugs can go to work and help protect crops and feed these crops, right? Opposed to an environment that might have little to no organic matter, no moisture management. I mean, there the bugs aren't going to be working well. So really, really stressing that part about that integrated approach. Now, when we think about developing a biological industry and what's going on and what happened in the past, when we start looking at Western Canada and the Northern Great Plains, including the North Dakota, Montana, that type of environment, in the 90s or late 80s, there really was no biological industry to where we are today, and we're a very large pulse producing region, and virtually 100% of those growers are using biologicals. There's more and more adoption all the time, and it's part of mainstream agronomic conversation. But the work that went into developing the biological industry was incredible, right? That it wasn't just a couple of bar graphs and yields, but it was an entire group of people working towards advancing this biological industry. And there's a lot of university work that happens in benchtop type of research, which still happens today, but it doesn't always get translated to an agronomic practice in the field. And there's a lot of barriers between that academic knowledge and applying it in the soil. And what I think was really great back in the development days was how many publications came out looking at how to make biologicals successful. And it almost seems like nowadays let's test biologicals until they don't work and then, work against them. Sometimes it feels like that. So when we look at the types of studies that were done, everything from just strain selection, right, and getting the right strains that will survive, that will colonize in the roots or in the rhizosphere or on the roots or in the soil, looking at robust strains that could handle environmental stress. I mean, that's a lot of work just goes into that. Then getting into things like rates and titration studies out in the field. And I feel like, there's less and less of that even being done, and more just looking at bug counts and looking at, competitor labels and copying what they do, and off they go, right? And we get into formulation work and think about some of the early formulations. I mean, we know that ease of use is incredibly important right now. So a product can't be cumbersome. And I think back to a product that we had early days at Jumpstart, it was called Provide, or even PB50. And it was a frozen puck that you had to kind of defrost in the field, and it had green dye involved in it. And it was just an absolute mess, right? So pretty interesting looking back at some of those early formulations to where we are now with, improved granular products and products that can be delivered in furrow with starter fertilizers. Ease of use is everything. So it has to be seamless into those agronomic practices. And then, I'll get into even some of the work that was done out there around, in collaboration with the universities. And one thing that I just don't really see a lot of right now is the publications from scientific proceedings and conferences, workshops, scientific papers that are where we have private industry and universities working together to publish and advance the biological industry. It's, again, that back to that slide around marketing is winning, right? That seems to be more of the approach, and it just seems the cycle that we're in right now, right? And there's a lot of great work done at universities, but it doesn't always dovetail into the private industry and making the biologicals just work better for us. So again, I'll have a couple examples here of just some of the early work that was done, and then I'll go through a little bit of how that can impact some products today. But when we look at, say, phosphorus solubilizing inoculants, again, a lot of research in the even 40s and 50s, Russian scientists were looking at penicillium bulli, and then Ag Canada got involved and basically started commercializing the product in about the late 80s and early 90s is when a company in Saskatoon called Film Bios bought the patent rights to penicillium bulli and started commercializing it. And it, up until then, it was just all basically scientific work. And now we're out in the field, and think back to this time in the early 90s. I mean, there was no biological industry, so to speak. There was a bit of inoculation with rhizobia on peas and lentils and soybeans, alfalfa, things like that. But as far as the phosphorus solubilizing bugs, or as far as the mainstream agronomic conversation, must have been incredibly difficult back then to go, into a grower meeting and say, hold up, a bag of biologicals and say, put this on your seed, and you're going to get a better crop, right? I mean, that whole concept was brand new, and the incredible amount of work going into the research, the science, demonstrations, field trials. I mean, this was year over year trying to make sure that things worked like they said they would. And, they got to a point where, now we can see this kind of technology all over the world. But, a lot of the work that went so far beyond just treatment versus yield. And we see so much of that, especially in that marketing material is, I know yield is incredibly important, but there's a lot of questions on to why and how, right? And that's really glossed over these days. But getting back to some of that fundamental research showing that, hey, you know what, we can look at, how the technology is working and how do we know that, right? Opposed to just, here's your 4 bushels and off you go, right? And so some of the early work that was done around tissue testing, looking at different fertility regimes, and really kind of drilling down into the whys and the hows, which, as I said before, is, I don't see a lot of it in today's commercial biological products in North America. And then we get into the scientific works. And I think that's, again, really adds that legitimacy to the biological industry. And so, we can see benefit of inoculation crops with rhizobia northern Great Plains, just the increases in available phosphorus. When we have the benchtop work and the work done from the universities backing up what we talked about, that's a really powerful tool to help build trust in biologicals, right? And get over that snake oil realm that I keep talking about. And again, just early, this is from printed journals that were photocopied, but looking at tissue tests and grain analysis of how much phosphorus went in. And again, this would have been coming from published papers, right? Not just marketing data for companies. This one I found really interesting was actually the use of radioisotopes, radioactive isotope of phosphorus, and working with the University of Saskatchewan here locally on the development of our phosphorus solubilizing technology, but looking at the radioactively labeled phosphorus and it not being available to the plant, right? And looking at with and without the technology. But when we can take data like this and say, hey, you know what, we've actually really proved this beyond a reasonable doubt that the biologicals work and it's doing what we say, and we're using science like this, it can back up our yield claims and it can make people a lot more confident. And this had to be done because there was just no biological industry out there. So the trust and the belief wasn't quite there yet, right? And again, I mean, I've got lots of examples here of just, different graphs that are used to show tissue uptake in different fertility regimes. And again, we just don't really see that, again, in North American type commercial products out there, the science that backs up these technologies that's out there. It's kind of a race to market, and who's got the latest whiz bang, who's got a couple of fancy bar graphs, maybe throw a couple hats at you, buy our product. And unfortunately, too, retail margins tend to drive the show a lot right now, too. Hey, sell this biological product over this one because we make more money at the retail level. Well, what about yield? What about, all that? Well, it doesn't matter. We're just here to make some more money with it, which obviously making money is important. But again, we want people to have the best possible experience with the technologies. And then just the amount of yield studies as well. I mean, the amount of work that had to go in, hundreds and hundreds of trials over diverse geographies, diverse crops, diverse fertility regimes to make sure it worked. And, when we can look at hundreds and hundreds of trials, here's, this is 836 trials, and all of that went into building trust, right? And establishing an industry. And because of that work that was done, and not just by, say, Novozymes and Film Bios, but at the same time, Becker Underwood was around Western Canada. That was spun into BASF, right? And, it's not a commercial for anyone right here, but there was a lot of development work that went into the biological industry. And that's why, we took something like nitrogen fertilizer for peas and lentils, which was the standard practice, and turned that into basically 100% inoculation, and showing that actually nitrogen fertilizer inhibits nodulation. We can use this source of biological nitrogen. It's a lot cheaper, a lot more sustainable, and off we go. And here we are today. So it was really about, building that trust. And at the same time, it was a very different regulatory environment with our governments. At the time of product registration, you had to prove efficacy, right? Alongside seed safety and phytotoxicity, environmental and human safety, efficacy was a big part of the program. And so you had to prove to the government that, hey, this stuff actually works, and here's my data package to register the product under the Fertilizer Act. And I know today that's not the case with biofertility products in Canada and most of the United States. EPA doesn't require efficacy data for fertility products, and state by state is a different case. And so, but it goes beyond that as well. Back in that day, there was minimum titers and on-seed minimums as well. And so that had to be, guaranteed, and that was tested. And at the retail level, I'm not sure if it was CFIA at the time, but we'll just call it Agriculture Canada, would go to the retails and take products off the shelf and test it for their titer levels and their viability. And all of this was building trust. I said, but it's a pain in the butt, but that's how the industry was developed, and that's how trust was gained. And today we're in an environment really where we've taken out a lot of the regulations around biologicals, and some people can argue for the ease of entrance into the market, right, and keeping an open market and that buyer beware environment. So there's two sides of the coin. One is easy entrance to the market, and one is a regulated market that has a little bit more quality assurances to it. But where we are today is very much in a buyer beware market. And that's where you have to prove your products and get out there and make these relationships and get the growers' ear, get the retail's ear, and build trust with them. And we do that, I think, through robust trials. In Canada, we use a lot of grower trials on farm and third-party cooperators. In the United States, we do a lot of work with universities as well. We don't really have that university system in Canada to go out there and work with them just to test our products. It's a bit, our extension divisions are not really present out here, but we need to have all of it in order to say, hey, we've got a robust data package. We can publish that data. It's not, two trials that look good, cherry pick that data, shine it up with some marketing dollars, and then again, we're into that buyer beware. So how I like to look at it is really through kind of three lenses: the science, data, and agronomy lenses. And I look at it like a three-legged stool, where if we don't have one of these legs holding up the stool, it falls over. And so science is that kind of that robust understanding of, say, the organisms or the signal molecules, how they work, what their metabolites are, what their life cycles are, right? And understanding that academic nature of these biologicals, but then matching that with agronomic practices. And as I said, ease of use is incredibly important. So having to match what's going on in the field and looking at how it fits agronomically, as I said, with possibly that, say, 20 pounds of available phosphorus, backed up by the science, also backed up by the data. And data can mean different things to different people. It's, people always ask for more data, and then you provide it to them, and it still seems to be, oh, well, we need more, right? And it's at some point, how much data is enough, or what's the ideal data package? But I think we still need data, and not just the treatment versus yield data. And I think that's where we start thinking about, what types of trials are important to help prove, okay, yes, 8 times out of 10, you'll get 7% increase in yield, but also the why, right? And I think the why is important because that's going to impact the agronomy, and that's going to help us just with the overall understanding and success of biologicals. So just quickly, I know we've gone for about half an hour, but I can look at a couple examples of that. So in our biocontrol realm, we look at the science, and again, not just yield, but when we make claims around inducing natural resistance, we have the genetic work that shows the upregulation of the genes involved in the salicylic and jasmonic acid pathways, and that in this case, that in the presence of this bacillus product, we're seeing 27 times more expression of proteins involved in plant protection, right? And so that's that really academic nature of plant protection and the upregulation of internal defense mechanisms of the plant. We can look at the metabolites that are produced and the antibiotic, antifungal metabolites that products like streptomyces or bacillus make, give us that academic nature of these products, and also affect safety and thinking about, are they human antibiotics, right? And we want to obviously avoid anything to do with that. And then just how it works out there, how it colonizes the intracellular space, right? How these organisms are looking when we look at it through those scientific lenses. And then the data, again, we can have hundreds and hundreds of trials, the treatment versus yield trials. Again, for protection products, we want to make sure that our products do need to be proven in that case. So good data packages, diverse crops. I mean, these are all things that will help us be successful in the understanding of our technologies. But again, going even beyond yield and looking at things like, how does it compare to beneficial insects? In this case, these are biofungicide products. I'm not trying to be a commercial for Tegro, but I'm more talking about the types of research that can lead to success with biologicals, right? And in this case, we're looking at how this biofungicide affects beneficial organisms, say in greenhouses, and basically this product would be very similar to water. But again, it's building up that trust and building up the understanding of the products. Weather and pH conditions, what's going on? It's not, again, just, hey, we're going to give you, 7%. When is it going to work? How is it going to work? What can we expect from the product in order to be successful? And how does it work in terms of how do we apply it? How do we be, dovetail into current practices so it's super easy, right? And then obviously, what are the targets and what are the disease targets? And then, as I said, with the phosphorus piece, I'll just, kind of buzz through this. You guys have seen some of this already, but, understanding the science behind the products, how they work, what are these organic acids that's being produced, where are they being produced, under what pH, under what temperatures are they going to grow. All of that helps form our body knowledge that is going to impact the agronomic fit. And in this case, we know that we're dealing with phosphorus. Phosphorus is essential for life, right, as part of the ATP-ADP energy balance. So if we solubilize it early in the year, we can help that plant get up and out of the ground early in the spring. And then again, backed by all sorts of data, right? And this would be grower data with and without penicillium bulli present, single strain, double strain. Just looking at really the dozens and dozens or hundreds of data points year over year that are needed to be able to make claims showing that, hey, you know what, in this case, if we want to say we're solubilizing 20 pounds of phosphorus per acre, why are we saying that? And what are the data points or what are the trials that have shown us that, hey, we look like 20 pounds an acre? And I just, again, we have more competitors in the, say, the phosphorus solubilizing space, and I just don't see the work. And I dig into websites, I dig into cell sheets, and it becomes very, very thin. And it's, people can make claims like, oh, we're the, the benchmark of phosphorus solubilization, based on what, right? Based on because you say you are, or based on dozens of years and dozens of years of trials and research and development, right? So that buyer beware marketplace is incredibly strong right now. And I think, maybe we've even seen peak biologicals, and now we're going to get back to the fundamentals of how to make it work and develop the type of research programs that are going to make biologicals successful. Because if we just keep coming out with more products, more claims, and it's just buyer beware, eventually that's going to fold in on itself, right? And so that's, I think we're headed in that direction. But I think we need to be deliberate with our approach, and that if we are looking at systems approaches to crop management and sustainable agriculture, right, that's going to include biologicals, right? We know that they're an incredibly powerful tool, but we also know, or are starting to understand, about the environments that they work best in. That it's not just, heavy tilled soil with a heavy chemistry program with no attention to organic matter and tilth and moisture management, right? If we just keep dumping biologicals into that system, let's say, a corn soy rotation with 6 passes of fungicide and herbicide and preseason burn off, that environment's probably not going to be successful for biologicals. And if we test in that environment, and even just for yield, these biologicals don't work. These biologicals don't work in that environment. You put them into, say, a system that has a lot of focus on organic matter management and moisture management and cover crops, things like that, much more likely to be successful. And so, I have this even vision of research stations and research land being part of a regenerative agriculture type system. And then you overlay the biological research and even regular research into that system, right? That it's not just looking at the one variable, treatment versus yield, that it's looking at a number of variables and also in different environments. And if we can do that, we're going to make biologicals become more successful. So again, just education is key. It's grower retail education. I do a lot of talks and a lot of outreach talking, and so does my counterpart in the States. For us, this is all we're focused on is biologicals, right? This is all we really do. I'd like to see more published material as well with commercial products in these systems. I think that would just add to the validity of the whole industry. And demos, retails, all that stuff is incredibly important. And hopefully, we can get to a place where we are part of that mainstream agronomic conversation, and that there is a lot of trust, and that we really step out of that snake oil realm, and we do that with good research, and you guys are all part of that. So that's really what I wanted to get down to today. I know we're running a bit late. I'm not sure if there was question time or anything like that. They could always get typed in the box. If not, you can reach out to me. Like I said, in the presentation here, my email and phone number were at the beginning, and I really enjoy talking about this kind of stuff. And thanks to Jim and Gary for inviting me to speak. I wish I could be there in person, but then I'd miss out on the -50. So, wanted to stick around. But turns out most of the flights this week have been canceled around here, so I probably couldn't have got down there anyway. So hopefully this worked out. But enjoyed this and enjoyed making this presentation. And again, thanks to the organizers and audience for listening.